Hi everyone, so today we're going to talk about the application of differentiation, which is related rates. So introduce our team members. The first one is Zulhelmi, the second one is Tias Anissa, the third one is Safwana Atira, and the last one is me, Aga Maisara. So for the introduction, why you have to learn the application of differentiation? The application of differentiation is to use derivative to solve the related rates problem. The second one is to use the first and second derivative to analyze and sketch the graph of polynomial and rational function. The third one is to use derivative to solve maximum and minimum problems. What is related rates? Related rate is a problem in which we know one of the rates of change at a given instant. Why we use related rates? If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing.
Now I will explain to you the application of derivative in our life. So as we know, the derivative topic are the most hardest topic in a calculus, but for your information, these derivatives are very helpful in our life. So first thing first is derivative help us to calculate the profit and loss in business using the graph. So for a company, it very helps the company to maintaining their profit and loss for a month or a year. Second one, derivatives help us to check the temperature variation. As we know, in these modern days, there are issues about changing temperature in a few states. So derivative help us to know temperature and also the variance of each state have. Lastly, derivatives help us determine the speed or distance covered. As an example, when we drive a car or ride a motorcycle to some place, derivative help us to know the speed or the rate that we have used along the way to the place that we want to go. Now, I will share to you about the tips that you can do to solve the related rates equation. There is 4 tips. The first one is list all out of the information that have been given from the equation. The second one is make an equation from the information that you have listed out. Then the third one is differentiate the equation using the chain rule. And the lastly, substitute the information into the differential equation and then solve it. That is the tips that you can do to solve the related rates equation.
Homework 42, question 2. A 13-meter ladder is resting against a wall as shown above. If the top of the ladder is being pushed down toward the floor at the rate of 1/4 meters second, how fast is the angle between the bottom of the ladder and the floor changing? d theta over dt when the angle theta is pi/6 radian. From the question, we know that dy over dt is negative 1/4 meter per second because the ladder is being pushed down toward the floor at the rate of 1/4 meter per second. And the question is d theta over dt, and we know that the theta is pi/6 rad. From these 3 keywords, we know that the equation is d theta over dt equal to d theta over dy multiplied with dy over dt. And now we're going to search for d theta over dy. From the picture, we know that theta is opposite with y and the hypotenuse is 13 cm. So we're going to write it like this. It's became sine theta equal to y over 13. And 13 sine theta equal to y, and we have to differentiate it, and became dy over d theta is equal to 13 cos theta, and d theta over dy equal to 1/13 cos theta. And we're going to replace it into the equation. So it's became 1 over 13 cos theta multiplied with negative 1 over 4. And we calculate it, it became 1 over negative 52 cos theta. We're going to replace the theta with the pi over 6, right? And the answer is negative 0.0222 rad over second. That's all from me. Thank you.
So for the next part, me going to discuss about homework 42, number 9. So a cylindrical can has a radius of r cm and the height is r plus 4 cm. So I've drawn to you that this is the r and this is the height for the cylindrical can. So the can is expanding at a constant rate of 5 cm cube per second when heated. So what is a constant rate of 5 cm cube per second? It is a dV per dt. So we know that the info is dV per dt is 5 cm cube per second. So for the first question, we're just going to show that the volume of the can is given by V equal to pi r cube plus 4 pi r square. So we're just going to put the V cylinder and the information to the V cylinder. So as you can see here, we just going to put the V cylinder is it equal to pi r square h, and then we're just going to put the height for the cylindrical can, and then we're just going to expand them, and then we're going to have this. So it is going to show that, and it is to proven that the answer is same as in the question. So that's all for the first part. So for the next question, we just need to find how fast is the radius changing at the instant when the radius is 3 cm. So first and foremost, we need to write dr per dt, and then we're just going to pecahkan dr per dv darab dv per dt. So we have dv per dt, which is 5 cm cube per second, and we just need to find dr per dv. So after that, dr per dv, v we have, and then after that we're going to derive them. So v, as you can see at the first question, which is A, we have v equals to pi r cube plus 4 pi r square. So we're just going to derive it, and it will become 3 pi r square plus 8 pi r. So we need to find dr per dv, right? So we need just to tukarkan tempat dia. And then after that we get the dr per dv. So as you can see here, we have dv per dt, and then after that you're just going to put into the formula, and then you're just going to put the 3 cm, which is the radius when the changing at the instant when the radius is 3 cm. So you just gantikan in the radius this one, and then after that you will get 5 per 51 pi. So that's all for my part. So thank you.
As for the conclusion, we learn how to solve the related rates problem, and we can also solve the derivative rules and implicit differentiation in the rates of change. And also, the related rates are the problems that involve two or more quantities and they are corresponding towards time. Simply, we can solve all the related rates question if we remember all the steps and formulae correctly. That is all from us. Thank you.